Hi, welcome back to Math 111. We're going to take just a couple of minutes today to talk about graphs of polynomial functions. Now, what's a polynomial? Well, the short answer is a polynomial is just a sum, it's a function that is made up of a sum of terms. And those terms can look like 3x squared plus 5x plus 1. That's a polynomial function. Another polynomial would be 9x to the fifth minus 4x to the third plus 3x. That's a polynomial function. 1 is a polynomial function. So is 7 or -7 or -9/5 x to the 7th plus 6x to the 6th minus 11/15 x to the 5th plus 3. Now, what do all of these functions have in common? Well, they've got a few things. They're all sums, so there's pluses and minuses. They all have only positive exponents, right? And in all of these cases, the variable is in a numerator. It's not in the denominator of the fraction. So, in general, a polynomial function looks like anything that can be rewritten or can be written as a sub n times x to the n. Now, don't let these n's freak you out. They are just counters. All this is saying is if you've got something that looks like a sum of numbers times variables raised to positive powers, or to non-negative powers to be more accurate, then you have a polynomial. Okay? Now, a few things about polynomials. Their domains are always all real numbers, or in interval notation, -infinity to infinity. Okay. So what else? Well, let's talk about a little vocabulary here, so we know so we all speak the same language. So we need to talk about the degree of a polynomial. The degree is the highest exponent applied to a variable. So, for example, the polynomial function g of x is equal to 9x to the fifth minus 4x to the third plus 3x. We have an exponent of 5 and an exponent of 3 and an exponent of 1. 5 is the biggest, so this one is a 5th degree polynomial. Another example, if we look at this j of x, which I wrote as -9/5 x to the 7th plus 6x to the 6th minus 11/15 x to the 5th plus 3. Again, we've got polynomial or exponents of 7, 6, 5, and this is actually an x to the 0. 7 is the biggest, so this is a 7th degree polynomial. Right? Now, I also told you that this guy, h of x equals -7, is itself a polynomial. Well, implied here, there's an x to the 0 because any number to the 0 power is 1. So this is a 0 degree polynomial. Okay? Now, we also can talk about terms. So the terms of a polynomial are the quantities that are added together. And so if we take a look at this guy, this j of x, he's got 4 terms. So the terms of this polynomial are negative 9/5 x to the 7th, 6x to the 6th, negative 11/15 x to the 5th, and 3. And each of these terms has a degree. So these are the terms of that polynomial, and they each have a degree. And the degree of a term is nothing more than the exponent that is applied to the variable. So this first term is degree 7. This next term is degree 6. The last term here is degree 5, and the 3 is degree 0. Now the leading term is the term that is of highest degree, regardless of where it occurs in the polynomial. And the leading coefficient is the constant multiplier part of that term. In other words, negative 9/5 is the coefficient of this term. So that is the coefficient of the highest, well, of the leading term, of the highest degree term. Okay, let's just do some practice with these. With this vocabulary a little bit. So let's look at the function g of x is 12x plus 3. Okay, first, 12x plus 3x squared. So the degree of this polynomial is 2. Because I have an exponent of 1 and an exponent of 2. The highest exponent is 2. The leading term would be 3x squared, because that is the term that includes the highest exponent. And the leading coefficient would be 3. Okay, now let's mix this up a little bit. We're going to do this work again, but we're going to do this with the polynomial that looks strange. So this is going to be 2x minus 1 to the 3rd power times x minus 2 times 3x plus 2. Okay, now here's the deal. This polynomial is in what we call factored form. If you remember all of the polynomials that I read out the first time, they were all written out. They were all multiplied out as sums, right? And we remember from Math 95 that we can multiply these two together, and we can multiply this out, but we'd really rather not, but we can. So, but here's what we're going to do. We're going to think about, because if I want to know what the term, so I can figure out the degree of this thing. So let's just do this work. Let's go ahead and expand this cubic, and I'm going to show you a shortcut for doing that. This thing that I'm gonna write down over here in the corner, a thing called Pascal's triangle. And Pascal's triangle, so how do you build this? Well, you start with a 1 and then a 1 on either side of it. Now, this 2 comes from 1 plus 1 is 2. So there's always a 1 on the outside, and then the sum of these two make that 2. And so a 1, and 1 plus 2 is 3, and 2 plus 1 is 3. So what does this do? Well, this gives us the coefficients of a binomial raised to a power. So for example, this is row 0, this is row 1, row 2, and row 3. So a plus b squared is a squared plus 2ab plus b squared. A plus b to the third is a to the third plus 3a squared b plus 3ab squared plus b to the third. So that means that I can expand this 2x minus 1 to the third power as 2x to the third power minus 3 times 2x squared times negative 1, plus 3 times 2x times negative 1 squared plus negative 1 to the third power. Now, all of this is still multiplied by these, but I'm going to FOIL these two together. So I'm going to get 3x squared minus 6x plus 2x is minus 4x minus 4. Okay, now simplifying this first bit, that's 8x to the third plus 12x squared, minus 12x squared plus 6x minus 1, all multiplied by 3x squared minus 4x minus 4. Now I'm going to multiply this guy through this guy, which really means I'm going to start with the 3x squared and distribute it through. Then I'm going to take the negative 4x and distribute it through, and then the negative 4 and distribute it through. And then when I'm all done, I'll combine like terms. Now this is the hard way. I'm going to show you the hard way, and then I'm going to show you the easy way here. Okay, so what am I doing? I'm expanding this guy all the way out. And I'm going to do that by doing this polynomial multiplication. So 3x squared distributed through. 3x squared times 8x to the third is 24x to the fifth minus 3x squared times 12x squared is 36x to the fourth plus 3x squared times 6x is 18x to the third minus 3x squared times 1 is 3x squared. Now I distribute the negative 4x through. So that's going to give me, and I'm going to go down a line because I'm going to run out of space. So negative 4x times 8x to the third is negative 32x to the fourth minus 4x times negative 12x squared is plus 48x to the third. Negative 4x times 6x is minus 24x squared. Minus 4x times negative 1 is plus 4x. And now I'm going to distribute the negative 4 through. And I'm just going to go down a line, and all I'm doing is I'm lining up my like terms. So negative 4x times 8x to the third is minus 32x to the third. Negative 4x times negative 12x squared is minus plus 48x squared. Negative 4x times 6x is minus 24x. And negative 4 times negative 1 is plus 4. Now I need to add up all my like terms. So this will be 24x to the fifth minus 68x to the fourth. And let's get a calculator out so I do that arithmetic correctly. Um, 18 plus 48 minus 32 is 34 x to the third. Negative 3x squared minus 24x squared plus 48x squared is plus 21x squared minus 20x plus 4. Now here's the deal. All I really care about here, all I really want at this point, I want the degree, which we can see is 5. I want the leading coefficient, which is 24. And I want something I haven't talked to you about, which is the constant. Constant coefficient, or sometimes we call it the constant term. But it's the number that doesn't have a variable. It's 4. This guy is the constant coefficient. Okay, so that was the hard way. Here's the easy way. Start back up where we started with. And notice I've got a 3 and a 1 and a 1. 3 plus 1 equals 5. So if I add up these coefficients in factored form, I get 5. I get the degree. And let's think about where this 24 came from. That came from 2 to the third power multiplied by 3. 2 to the third power times 3 makes 24. So I take the leading coefficient, and there's a 1 in here, of each of these factors. I apply the exponent that goes with it. So 2 to the third is 8 times 1 times 3 makes 24. And let's think about where this 4 came from. This 4 came from negative 4 times negative 1, but where'd that come from? Well, that came from negative 1 to the third times negative 2 times 2. So negative 1 to the third times negative 2 times 2 makes negative 1 to the third is negative 1 times negative 2 is 2 times 2 is 4. So you don't necessarily have to do all this work if all you want are these 3 things, because you can get all of that from the factored form. All right, I hope this has been helpful. We'll continue on in another video.